Good morning, my dear friends. Welcome back to my channel. Today, I am going to solve a interesting and easy question on Leetcode March 5th question. Question statement is count total number of colored cells. Count the total number of colored cells. Now let's go into the problem statement. There exists an infinitely large 2D grid of uncolored unit cells. You are given a positive integer n. Let n is a given integer, indicating that you must do the following routine for n minutes. What are the following steps we should consider? At first minute, color any arbitrary cell to blue. That means if n is equal to 1, we should color at first minute, we should color first box as blue. Every second, every minute thereafter, color blue every uncolored cell that touches a blue cell. This statement tells that if a box that is colored blue, the boxes that surrounds on all the directions of 4 directions, we color blue. Let's see a pictographical representation of this. Here it is clear that for n is equal to 1, the box that is, this box will be colored blue. At n is equal to 2, the box that is surrounding, for n is equal to 1, that is surrounding the box will be colored blue. These boxes will be colored blue. For n is equal to 2. Now, for n is equal to, let's see, for n is equal to 3. Initially, at n is equal to 1, this box will be colored blue. Now, at n is equal to 2, the boxes that is surrounding this box will be colored blue. 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 At n is equal to 2. For n is equal to 2, these boxes will be colored blue. Now, at n is equal to c, n is equal to 3, given n value as 3. What happens at n is equal to 3? Let's see. At n is equal to 3, first the box surrounding this box will be colored blue. That means these are surrounding this box surrounding these boxes. It is already, this box is colored already blue, so we leave. Now for this box, let's see, this box will be this box is surrounding this box will be colored blue. This box will be colored blue. Now for this box will be colored blue. This box will be colored blue. Now for this box, listen carefully, friends. For this box, this is already colored blue, this is already colored blue, this will be colored blue. I am going to explain again. Initially at n is equal to 1, this box will be colored blue. At n is equal to 2, these boxes that is surrounding these boxes will be colored blue. These boxes will be colored blue. Now at n is equal to 3, this box is surrounding this box. This will be colored blue. This will be colored blue. Now for this box, the box surrounding this is this box. These two boxes are already completed blue color. This box, it is colored blue. Now for this box, it is already colored blue. This is also already colored blue. So other two boxes are colored blue. These two boxes will be colored blue. Now for this box is already colored blue. This box is colored blue. This box is colored blue. Now remaining box is this. This box is also colored blue. Now how can we approach this problem is, how I approached this problem is, I initially go through some methods, some mathematical ways. How can I solve this problem? I found that for some values of this, initially let's see some cases where n is equal to 1. We have how many number of boxes? We have one number of box. For n is equal to 2, let's see how many number of boxes are there for n is equal to 2. For n is equal to 2, we have 1, 2, 3, 4, 5 boxes. For n is equal to 2, we have 5 boxes. For n is equal to 3, we shall count how many number of boxes are there at each level. At this level 1, at this level 3, at this level 5, at this level 3, at this level 1. So number of boxes will be 13. Number of boxes are 13. So 13. Here I approached some, for n is equal to 4, it might be the value of, for n is equal to 4, I have counted that it gives 25 number of boxes. Here we can see one progression is happening. For n is equal to 1, n is equal to 3, n is equal to 2, n is equal to 3, we have 13 number of boxes. For n is equal to 2, we have 5 number of boxes. For n is equal to 3, we have 13 number of boxes. For n is equal to 4, we have 25 number of boxes. Similarly, we should count the number of boxes for n is equal to n value. It is in progression. The difference between these values is 4. This difference between these two values is 8. It is similar to sequence solving problem. The difference between these two is 12. Here we see this value is increasing GP, geometrical progression. The difference between these two values is 4. These two values is 4, and so on. The value will be constant. We should solve this progression so that we can get the problem solution. How we can solve this problem? There are two approaches for this. We can solve this using quadratic equation also. We can solve this using quadratic equation or logical equation. Logic. Suppose, what is this logic is, for n is equal to 1, we have one number of box. We have one number of box. For n is equal to 2, we have 5 number of boxes. For n is equal to 3, we have 13 number of boxes. For n is equal to 4, we have 25 number of boxes. For every minute, for each box, 4 number of boxes will be added. For each minute, 4 number of boxes will be added. So initially, no number of boxes will be added. So for first minute, 1. Initially 1 box will be there now, and no number of boxes will be added. 0 into 4. For next minute, n is equal to 1 number of box will be there, plus another minute 1 into 4, because 4 number of boxes will be added for the 1 box. For the next minute, we have calculated up to n is equal to 2. The value is 5. For the next minute, for each box of 2 boxes will be added. 2 number of 4 boxes will be added. For the next minute, this calculated value is 13. 13 plus 2 into 4, that is 25 number of boxes will be there at n is equal to 4. Here we can see that here we are using the previous calculated value. Let this calculated value is kept in answer variable. It is of type long because we should return the value as long value. Initialize long answer is equal to 0. This is the problem pseudocode. These values are increased 3. Here it is 3. Here this value is variably changing, so we can keep this value in as I. This value is constant. For every iteration 4 number of boxes will be added. This is constant. This is variable which is used to calculate the which is used to store the previously calculated value. Let it be answer variable. So coming to the pseudocode of this, let long is equal to long answer is equal to 0. Long answer is equal to 0. Let the variable I is equal to 0. We doesn't know how many times we should iterate, so we use while loop. All of them know that. I think all of them know that when to use while, when to use for. Let me tell shortly. When the iterations are known previously, we can use for loop. When the iterations are not known correctly, but we can use while loop. While I is less than n. While I is less than n. I is less than n. Answer is equal to answer. We are storing the previously calculated value and adding the previously calculated value to the present value of I into 4. We can see why I into 4. It is variably changing. This value is variably changing. This value is variably changing. This is constant. For every iteration, this answer, previously calculated answer, is stored and calculated further. While I is less than n. Answer. For every iteration, we increment answer. Now return answer. After while loop, we return answer. Here we initialize n as 1 because initially for n is equal to 1, one box will be there. So we initialize n as 1, answer as 1 for n is equal to 1 box. Now let's see the pseudo. Let me explain how this problem solution will be. We can get. Let's suppose n is equal to 3. N is equal to 3. Answer is equal to 1. This is the how the variables will be changing for every iteration. We can see it is like we are seeing how the answer, how can we get answer in that way. Initial I is equal to 0, n is equal to, now it initializes answer variable as 1 and initializes I is equal to 0. Now it checks the condition while I is less than n. I is less than n. While I is less than n. So it goes into the loop. Answer is equal to answer. Previously calculated value of answer is equal to answer 1 plus I 0 into 4. Answer is for n is equal to, for I is equal to 0. Answer is equal to answer plus 1 plus 0 into 4. 0 into 4, that is equal to 1. Now increment I as 1. Answer is for I is equal to 1. For I is equal to 1. I is equal to 0 is this. For I is equal to 1. Answer is equal to, previously calculated answer is 1. 1 plus 1 into 4. That is equal to 5. Now we see I is equal, we increment I value as 2. I value, increment I value as 2. For I is equal to 2, for I is equal to 2, answer, previously calculated answer as 5 plus 5 plus 2 into 4, that is 8 plus 5, that is equal to 13. I is now increment I is equal to I plus plus, that is equal to I is equal to 3. Now checks the condition in while loop. I is not less than n, so this condition is false, so it returns back to this return statement. Now returns answer. Return answer as 13. For n is equal to 3, we get the answer as 13. Let's cross verify the answer. For n is equal to 3, we are getting 13. So I think this problem statement and approach is clear to you all, and this is the one of the approach to solve this problem. If you have any doubts, you can comment me below. So thank you, goodbye, subscribe to my channel friends. Thank you once again. Have a nice day friends.